Alright, hi guys, today we're going to be doing this Further Maths paper. Let's just get into it. Just a reminder, this isn't supposed to be something you just watch and fully understand, because I'm not going to lay out every single time I take away a variable from like an equation or something. Every single time I add two numbers together, I'm not going to show it. I'm going to skip a few steps, just like those steps, not the entire question of course, but those steps. So if you, like, pausing it will probably be necessary if you want to actually get something out of the video. Right. Let's just this question is like this. People have been saying to me to just go into not skip any of the questions of the paper like I did in the first episode. So we're gonna try that in this episode and see how it works. For this one, it's just factorizing. It's nothing that difficult. We can see that 6w is the highest common factor of this, so you just factorize it out. This question is just a normal midpoint question. You know that 6 plus a over 2 equals -1 because that's how you find a midpoint. You just add the two values and then divide them by 2. Then you just solve for a, do this, you get a. Alright, so this is actually quite difficult for question 3. So first you're going to multiply as matrices. You do all this stuff here as normal. Then just get them together, make all the calculations, multiply it by 3, you get this. But the real difficulty is this next part. So if you multiply to get the first columns, you get 14 plus a cubed equals 78 from multiplying this by this, and then you just solve for a here. And then with this next one, you get an equation with the a's and the b's, but because we already know a, you can just substitute the a in to get to the value of b, which would be 16. Alright, so we got this next question. It's about parallel lines. So we know that it's parallel to this line here. It's just a rearranged version of this. You can just write it as y equals -4x plus c, because we know that it's parallel, so the gradient's the same. So now let's substitute these points in here. You get find c, which is 9. So we get y, this is the equation of the line we're talking about with this point on it here. So now we can just substitute the d's into the equation and get this, and now we can just solve for d. Alright, so this is, I don't even know how this got here. This is literally just, you solve this, x equals plus or minus 4. It says negative value, so it's at -4, and you just say that x could be -3, -2, and -1. Like, it's really, I don't know why this is here. Next question, this is just proof. Expand everything. I've rearranged it to make it a bit easier to see why these cancel out. You just get 8n over 4, and then you've got 2n. Right, so we just got some product rule here. This first number, out of these numbers, it can only be 2 and 3, because none of these numbers will be 200,000 or 400,000 in between them if it's the first number. So the first number in this multiplication will be 2, because there's 2 possibilities. But all the other numbers in this set of numbers can fit into any position. So we'll just do 2 times 5 factorial to find this product rule thing out, which is 240. Right, great. This is already not been animated, but it's fine. We have this just derivative question here. It's telling you to find it when the gradient is 4. So we just find the derivative, which is this. Then we set it equal to 4 and put it in terms of what the question wants us to put it into. So that's 2 marks. And then for this last bit, you just use quadratic formula on this. Alright, so we got some nth term now. we have just this first question is just a 1 mark question. You add another 4k onto it. As you can see, this is just the sequence. For B, you need to know the 100th term is 30 plus 396k, because it goes up in 4ks, but the first one is plus 0k, so you need to take away 4k from the 100th one, from 400. And now we can just set it equal to 525, which is what it says here, and then just solve 4k. Alright, this is just some exponential graph stuff. We can see here there is no negative here, so it's not going to be A or B. And for the last bit, we know that this is the equation, and we know that this is when x is 0. So we're just going to substitute the point 0, 0, 3 and 0, 6 into the equation. And we know that 3 times 2 to the 0 equals 3, which means that y is going to equal 3. So it's not going to be this one, it's going to be D. Alright, this is just trig, but they've added some range stuff here. But we're just going to pretend that A equals 5 and then set it at the end, just because that's easier instead of having to solve an equation for A. We firstly use our inverse cos to find this angle here, which is just 5. We set A to 5, and so it's cos negative 1/2, which is 60. So we know that x is less than 60. And because degrees must be above 0, you can't have negative degrees. It also must be above 0. Alright, this is less of a derivative question and more of just indices, as like one of the marks comes from derivative, the other 4 come from working out this into one polynomial that doesn't have a divide. So firstly, we're going to factor out the 4x squared into 1 over 4x squared, and we're going to get the x squared out of there as well to x to the power of negative 2. Then we're going to get the x to the power of negative 2 into the polynomial that we have. So you see we get this, and then we're going to expand the 1/4 into it. So, because if we were to do it all at once, it would become a lot more complicated, so we just do it one at a time, which is a lot more simple to find this final polynomial here that we're just going to derive and substitute negative 1 into it, and you get 6.5. Because this is a calculator paper, you can just substitute negative 1 into both of these x's. Alright, so we've got a easy circle question here. The easy part is finding A and B, so we're just going to find the midpoint, which is 1, 9. Then we're going to put this into the equation. Now we just need the radius, which this is r squared here. And to do this, you use Pythagoras. You might be wondering, where do you get 6 and 8 from? Well, if you look at this diagram here, this is the circle and these are the points. You can see that across this is from 2 to 4, negative 2 to 4, there is 6, and from 5 to 13 there's 8. So you just use Pythagoras to find this diameter. And from that we know that the radius is 5 because it's half the diameter. And we now know that this is the equation because it's r squared. Alright, so we've got a circle theorem here. It's just, we know that PQR is 40 degrees smaller, so we can use an equation here by using the cyclic quadrilateral circle theorem to see that 4x plus 15 plus the same angle minus 40 equals 180, and you just expand, simplify, and just solve for x. Alright, this next question is very annoying, but you just have to make it into a single fraction, which you do by making the same denominator, and then you also flip the fraction and also take the root out of it by just dividing by 2 by using power laws. So now we can just put this into a single fraction and we can multiply them, and then you can just simplify it down. I've kind of oversimplified this first step a bit, but because I've done this fraction simplifying and also this fraction in the same step. So just be careful on that one. Alright, this next is just some trig. So we know that this bottom left angle here is going to be found using the area of a triangle rule, as we know the area of a triangle. We're just going to simplify this to sine c equals 120 over 256. And we know that sine -1 of that is going to be around 70. It doesn't really matter the rounding because AQA is really lenient with how the rounding systems work, unlike NXL, who don't let you round at all. Now we just need to remind ourselves that this angle also equals y, and we can just do this to find the angle because we know that these two angles are the same. Alright, so now we've just got some simultaneous equations. These, I hate these. These are one of the least fun things. It's just one of the most boring things you can do. It's just finding as many equations as you can and just hoping that you don't mess up. So firstly, we're going to double the first one and take it away from the third one. So this is doubling the first. This is it being taken away from this one here. So it's the third take away, double the first. And then after that, we'll double the third one and take it away from the second one, which gives us this. And then we have two equations. We got lucky and we got two equations with the same variable, and we can just add them together. We're gonna multiply this one by -1 to make it easier, and then just add them together to get 8c equals 24. And then after this, you can just substitute the values into the equations that we found. So you substitute the c into this one, sorry, and then substitute both values into the top one. Alright, so we've got some 3D trig here, even though it's mainly Pythagoras. We're firstly just going to label the side that it doesn't label, this AP. Then we're going to use this ratio. We know that HG equals AB because it's a rectangle. And because of this ratio here, we can find HP and PG. Just going to label them. Now we can find AC, which is this line here, by just using Pythagoras, and we can label that. And now we can find PC by also using Pythagoras, and you get this long number here. And now we're going to use inverse cosine rule to find this angle it's asking us to find. And we're just going to use calculator, set these values here. You know that A is the value that is opposite to, so 41 will be the A value, and you get APC equals 85.73 degrees. Alright, so I don't know why this is here. This is just some random triple bracket that they threw in at the end. It's just, you just expand it. I'm not going to write the entire grid method down because it's just long. You probably know how to do this. It's in the normal GCSE. It's not like a high grade topic either. Alright, so we've actually got an interesting question here. We've got a factor theorem question. This first one is pretty simple. You just find that it's telling you to compute a half into the function to make it output 0, as that's how factor theorem works. When you input the factor in, it will output 0, that's how you prove it. But the second part, you have to firstly divide 2x minus 1 by this cubic here, using whatever method you want, and you get this. And what's special about this quadratic is that it's binomial, so it has the same number, and that means that because this is binomial, and we already know that this is a half, which is another solution, this quadratic gives us the same solutions, which is just one solution. It's kind of weirdly explained, but that is the last mark, the statement. You just have to say that this is the same solution. Usually there is two solutions here. Alright, this question, you can use inverse tan, but the thing is tan graphs are a lot more complicated than sine graphs and cos graphs. So what I'm going to do is convert it into sine using identities and then do that, as it makes the last steps a lot easier and a lot more reliable. So if if you're just going for like 2 or 3 marks, you use tan and you find one of the values. But if you're going for all 4 of the marks, then it's probably easier to use a sign graph. So we're going to remind ourselves of the identities here. And we're going to do this first. So tan squared x is just tan x times tan x, which equals sin x over cos x, as over here. Then we just put them together. Now we put the 2 into the numerator and then multiply it by cos squared x. And now we know with the other identity, we know that cos squared x equals 1 minus sin squared x. And we just expand that. And then we're going to add 3 sin squared x to both sides to get 5 sin squared x equals 3. And then we're going to solve sin x equals root of 3/5, which gives us 50.8, and then because it's a sine graph, also 180 minus 50.8. So these are the answers. There actually would be other answers because this would equal plus or minus root 3/5, but the mark scheme doesn't require you to use the minus answers as well as the plus answers. So it is absolutely fine. Alright, this last question is, I don't even know what to say, it's really not that bad for a last question. So we're just going to simplify both of these. We're going to just say that this is 2 to the 4x to the x, and then say this is 2 to the negative 3x. Now, 2 to the 4x to the x, you just use your power rules. It's 2 to the 4x times x, which is 2 to the 4x squared. And then now the base is the same, we can just compute it like this and just solve by dividing through. Of course, x does equal 0 because it's power laws, but it does say non-zero up here. Alright, fast explaining, fast video, but thanks for watching, hope it helped for what you're doing, just a bit, because the mark schemes for further maths are absolutely atrocious, so just hope it helped. Alright, see you guys.